The rugged Grampians Range in Western Victoria might not be as famous as Ballarat or Bendigo in gold rush lore, yet it witnessed its own short-lived gold frenzies. In fact, it is the place where the last major 19th/early 20th century style gold rush occurred in Victoria. There was a rush in the 1980s to Wedderburn using metal detectors, but Mafeking was the final major traditional alluvial gold rush in Victoria. Throughout the mid-19th century, and even as late as 1900, eager prospectors swarmed into this region whenever whispers of gold arose. Unlike the sustained bonanzas elsewhere, the Grampians gold rushes were brief flashes. Towns sprang up virtually overnight and then vanished, leaving behind whispering ghost sites. But what made gold appear in these sandstone mountains at all? The answer lies in the fascinating geology beneath the Grampians. Today we'll explore all the areas that worked and uncover why gold exists here. Now, I've already released a video that covers the formation of the Grampians, the link to that is in the description, but as a brief overview, the Grampians are predominantly composed of hard sandstone beds formed over 400 million years ago. On the surface, this geology doesn't scream gold. Sandstone itself is not an auriferous or gold-bearing rock. However, the key lies deep beneath and around these ranges. The Grampians Range was formed from thick beds of Paleozoic sandstone, the Grampians group. These sandstones are quartz-rich, hard, and relatively chemically inert. During the Devonian period, the Grampians region was caught up in the Lachlan Orogen, a major mountain-building event. This orogeny, specifically the late Devonian Tabarabaran orogeny, caused the sedimentary layers to be folded, faulted, and uplifted into a towering range. The Grampians' famous vertical sandstone beds and dramatic escarpments are direct results of this tectonic deformation. Importantly, the same orogenic processes that uplifted the Grampians also introduced conditions for gold mineralisation. Orogeny typically involves tectonic compression, crustal heating, metamorphism, and the intrusion of magma. In the Grampians area, Devonian age magmas intruded upward and cooled at depth, forming plutons that poke into or beneath the sandstones. Several such plutons exist around the margins and underbelly of the Grampians. These granites, granodiorites, and felsic dykes are classified as I-type, or igneous-type intrusions, and are part of a broader suite of post-orogenic felsic intrusions in Victoria. In the Grampians area, we have a few different types of intrusions going on. We have granite, granodiorite, porphyry, and felsic dykes cutting through the sandstone layers. These felsic intrusions, like the granodiorite, can act as source of metals like gold under the right geological conditions. Crucially, as the intrusion solidified and the region's rocks were squeezed and fractured, hydrothermal fluids circulated through the crust. These hot fluids, essentially hot pressurized groundwater, often enriched with silica, carbon dioxide and metals, were capable of dissolving gold from the rocks and redepositing it in cracks and faults as the fluids cooled. This process is the essence of orogenic gold formation. Gold concentrated from large volumes of rock by metamorphic or magmatic fluids and precipitated in structural traps like quartz veins during an orogeny. The Grampians' dominant rock unit, quartzo sandstone of the Grampians group, is not inherently unfavourable for gold deposition. In fact, many gold reefs in Victoria and globally are hosted in sandstone, particularly where those rocks have been fractured, faulted, or chemically altered. However, in the case of the Grampians, the sandstones are exceptionally pure, massive, and structurally rigid in many areas, which can limit the extent of fracturing and reduce the pathways for hydrothermal fluids. Additionally, these sandstones typically lack the iron-rich or carbonaceous layers found in the gold-rich turbidites of the Bendigo and Stawell zones, layers that help chemically precipitate gold from mineralizing fluids. As a result, while sandstone can and does host gold reefs elsewhere, the specific conditions in much of the Grampians were less conducive to large-scale reef development. Nonetheless, where magmatic intrusions and major fault systems occur, such as around Mount William, they created localized conditions favourable for gold concentration. In these zones, hydrothermal fluids exploited fractures and formed minor quartz veins and alluvial deposits that carried enough gold to attract prospectors, albeit briefly. Another factor in the Grampians is erosion and alluvial concentration. The mountains that rose in the Devonian have been exhumed and worn down over tens of millions of years. During the Tertiary period, roughly 2 to 65 million years ago, extensive weathering and changes in river systems occurred in Victoria. Even a small amount of gold, dispersed through a granodiorite or vein, can be gradually freed by weathering and then concentrated by water flow into placid deposits. The Grampians saw exactly this happen on a modest scale. Gold that originally crystallised in granodiorite or veins was later eroded out and transported into old creek beds, where it became accessible to future prospectors. In summary, the stage was set in the Grampians for small gold deposits. A combination of orogenic processes, granodiorite, granite and dike intrusions, subsequent faulting and long erosion could yield isolated patches of gold. It was in such places that the gold rushes of the Grampians sparked to life. We've partnered with Geologie for this sponsored video, and speaking of finding hidden gems like those in the Grampians goldfields, I've discovered a skincare treasure that I'm excited to share with you. When exploring the rugged landscapes of the Grampians, preparation is essential. Similarly, proactively caring for your skin can help prevent aging and keep it healthy. Geologie makes this simple by offering personalised skincare tailored specifically to your needs. My absolute favourite lately has been Geologie's Retinol Night Cream. This cream, formulated with 0.2% retinol, niacinamide and hyaluronic acid, gently yet effectively promotes rapid skin cell turnover. It visibly minimises signs of aging, controls excess oil, and dramatically improves skin tone and texture. After using it consistently, I've been waking up to clearer, younger looking, and more radiant skin. Geologie's approach is straightforward and backed by real results. They've earned an impressive 41 grooming awards from respected outlets like Men's Health, Esquire, and Oprah Daily, and have over 10,000 5-star reviews from satisfied customers. For this month only, Geologie has an exclusive offer for my viewers. You can grab your personalised skincare trial set completely free. Yes, 100% off. Plus, you'll receive a free gift and up to 50% off additional products. Don't miss out on this amazing opportunity to elevate your skincare routine. Click my link or scan the QR code and use the promo OzGeology100 to claim your free trial from Geologie today. Trust me, your skin will thank you. The largest and most famous gold rush within the Grampians was the Mafeking rush of 1900, centred near Mount William in the southeastern Grampians. Mafeking's story is a classic tale of an unlikely discovery in rugged country. In the late 1890s, two wood splitters, Arthur and David Sashi, were working in a dense bush south of Mount William. In 1897, they spotted something glinting in a gully that cut through a local granodiorite outcrop. It was specks of gold. Realising they'd found a potential goldfield in the Grampians, the Sashi brothers informed two friends, Philip and Frank Emmett. However, at the time, the find did not immediately blossom. The Emmett brothers were busy at the Ararat diggings, and only later decided to follow up on the tip. It wasn't until June of 1900 that the Emmets thoroughly prospected the area. At a spot called Mason's Falls, they washed gravel and indeed got the first gold in payable quantities. They quickly registered a claim on June 24th of 1900, and word of the discovery spread like wildfire. Within a fortnight, a rush was underway. Hundreds of prospectors, undeterred by the remote, thickly forested terrain, flooded into the Mount William area of the Grampians. Rich gold was soon found in at least 10 different gullies, radiating from the slopes of Mount William. A makeshift tent town sprang up, which was eventually surveyed and given the name Narrum Narrum, though many simply called the field Mafeking after a contemporary newsworthy siege in the Boer War, which had captured the public's imagination. The Mafeking rush was remarkable as it occurred in 1900, decades after the great Victorian gold rushes. It was something of a last hurrah for Victoria's gold era. About 3,000 men at its peak reportedly flocked to this new field, hoping that the Grampians had one more El Dorado to give. Geologically, the Mafeking or Mount William goldfield turned out to be an alluvial field fed by a strange source. Mount William is underlain by Devonian granodiorite pluton and felsic dykes. We have a large body of intrusive igneous rock that had forced its way into the older sandstones, and dykes that exist around it. These intrusions were the key to Mafeking's gold. Tiny auriferous quartz veins permeate the granodiorite mass. These likely formed as the igneous body cooled and expelled hot fluids that deposited quartz and gold in cracks. It's also possible that gold is hosted in the dykes that circle around the granodiorite. The veins were generally small, often just a few centimetres thick and low in grade. On their own, they were too small to be worth mining hard rock, but over millions of years, those veins did not remain in the hard granodiorite. Weathering attacked the outcrop, breaking it down grain by grain. Quartz is tough, and gold is even tougher. They resist weathering, so as the granodiorite and felsic dykes rotted, chemically and physically, under ancient tropical climates, gold from those tiny veins was released as free particles. Rain and streams washed these particles downhill. Over long periods, during the Tertiary, streams in the area laid down gravel beds on the slopes and valleys around Mount William. These gravels, sometimes tens of feet thick, became a rich repository of alluvial gold. At Mafeking, the productive gravels were found capping a plateau area and in gully floors over an area of roughly a square mile. Miners reported that the gold was extremely fine and well waterworn, indicating it had been carried some distance from its source outcrops and tumbled in stream action. Some of the oldest gravels were buried under later material and could be as thick as 30 to 70 feet or 9 to 21 metres. The richest gold was usually at the base of these gravels, on or near the clay ancient ground surface, a common situation in alluvial gold deposits. Interestingly, in places where modern creeks cut through these tertiary gravels, they had reconcentrated gold in newer, shallower deposits. This meant that a gully might have a rich modern pay streak of gold sitting just a few feet below surface, directly above an older buried paylayer on bedrock. A bonanza for the diggers who found such spots. Mining at Mafeking during the rush was therefore mostly alluvial mining. Prospectors sank shafts or dug trenches into the gravels to reach the rich bottom layers, then washed the auriferous dirt by panning, cradling and sluicing. Given the fine nature of the gold, miners had to be careful and thorough in washing to recover it. Coarse nuggets were virtually non-existent here, but the field proved rewarding enough. By contemporary estimates, about 100,000 pounds worth of gold was recovered from Mafeking in the early 1900s. At the gold price of the day, this was roughly 25,000 ounces of gold, or about 777 kilograms. Modern reassessments put the total gold output around 1 tonne of gold. This is a significant amount for what was essentially a cluster of hilltop gullies. It testifies to the surprisingly rich concentration that nature had already done by accumulating gold from the granodiorite and dykes over geologic time. Miners did give hard rock or reef mining a try at Mafeking as well. They hunted for the in situ source of the gold by digging into the weathered granodiorite bedrock in various places. Indeed, they found some of those small quartz veins carrying visible gold in the Mount William granodiorite. However, these veins were, as suspected, too small and patchy to pay, meaning the gold could not be extracted at a profit from solid rock, given the technology and gold prices. Thus, Mafeking remained predominantly an alluvial field. Essentially, the Grampians granodiorite had been pre-crushed and pre-concentrated by nature, and the miners capitalised on that. From a geologic perspective, the Mafeking rush highlights a classic orogenic gold scenario, but with a twist. The gold was intimately tied to tectonic and magmatic activity. The Devonian intrusion of the Mount William granodiorite and dykes during the Lachlan orogeny, and to subsequent erosion and sedimentation. It wasn't a standalone magmatic gold deposit, like a porphyry or a giant hydrothermal lode. Rather, it was the product of orogeny plus time. The compressional forces of the orogeny created the granodiorite and cracks for veins. The fluids deposited the gold, then eons of weathering concentrated that gold into places. Mafeking was in essence a fossil stream bed of gold on a mountain, a geologically ephemeral treasure that the year 1900's fortune seekers were lucky to catch before it washed further away. After the initial rush of 1900, Mafeking's output waned. By 1901, the easily won gold was largely exhausted. Some mining continued in fits and starts for a decade or two. Indeed, the Mount William gold mine operated intermittently and the field officially produced gold up to around 1912. But no major reef was ever developed, and the population moved on. Today, Mafeking is a quiet locality with a handful of residents, but the gullies and water races are still visible, and the place holds an important chapter in Victorian gold history as the last great gold rush in Victoria. A few years before Mafeking's rush, a smaller gold excitement occurred deeper inside the Grampians, at Hall's Gap, the picturesque valley that is now the main tourist hub of the Grampians National Park. In April of 1897, reports emerged that gold had been discovered in Stony Creek at Hall's Gap. The news caused considerable local excitement. Hall's Gap lies near the heart of the ranges, and was not previously known for any mining, so a gold find there was unexpected. Nevertheless, prospectors hurried in and pegged out claims along Stony Creek for both alluvial gold and potential quartz reefs. Early prospecting did reveal gold. Very fair prospects were obtained from the creek gravels, meaning that panning had shown enough colour to be promising. This spurred hope that perhaps a payable goldfield was emerging in the middle of the Grampians. The Geological Survey dispatched a geologist to inspect the find and advise on its potential. His assessment was cautiously optimistic and geologically insightful. He observed that the alluvial gold in Hall's Gap Stony Creek was likely derived from a nearby granite source. In his report, he noted that the gold-bearing alluvium appeared to come, evidently from a bed of granite, probably intersected by feeders or dykes. In other words, he suspected that somewhere in the vicinity, a body of granite or a granitic dike was shedding gold into the creek, much like the scenario at Mafeking's granodiorite. He went on to say it was possible the prospectors might come across payable dykes similar to those found at Mount Wheels. Mount Wheels in eastern Victoria was another site where gold-bearing quartz veins in granite, essentially dykes, had been successfully mined on a small scale. This comparison shows that a geologist recognised Hall's Gap as a type of orogenic gold occurrence where a granite-related source could be feeding an alluvial deposit. True quartz reefs in the Grampian sandstones are very rare, but small silica-filled fissures do exist near these intrusions and faults. One report even mentions tiny quartz veins or silicified pipes in the area. Hall's Gap's gold was probably coming from such hidden veins or a disintegrating small granite or granodiorite stock at depth. In practical terms, the Hall's Gap goldfield, if one could call it that, never developed the intensity of Mafeking. It was more of a local prospecting rush. Early miners worked the shallow alluvial gravels of Stony Creek, likely in a stretch of creek that runs through the valley floor. Contemporary accounts noted that a considerable amount of gold has been obtained here from shallow alluvial workings, meaning that at least some gold was successfully won by panning and sluicing the creek's sands and gravels. The gold was undoubtedly fine alluvial gold, similar to Mafeking's, and was recovered from the modern creek sediments or thin layers of older creek bed. No spectacular nuggets are recorded. It was a matter of fine colours and the occasional picker. As the initial surface easy pickings dwindled, an ambitious plan was tried. In the early 1900s, gold dredges were being introduced to Victoria as a way to work low-grade alluvial deposits on a large scale, especially after the easily won gold of the 1850s and 60s had been mined out. Companies looked to rivers and old buried streams for remaining gold, using bucket dredges. Around 1908 to 1909, a small bucket dredge was brought to Stony Creek in Hall's Gap. This dredge would have been a barge-like contraption with a chain of buckets to chew through the creek alluvium and internal machinery to wash and separate gold. It was placed in Stony Creek's channel, or in a widened section of it, and it systematically processed the sediment, hoping to extract fine gold on an industrial scale. The dredging at Hall's Gap, however, appears to have been short-lived. By 1910 or soon after, the operation was discontinued. Hall's Gap's Stony Creek might have had gold, but apparently not enough to sustain a profitable dredging enterprise. Perhaps the gold was too thinly distributed, or the creek too small and rocky for efficient dredging. Whatever the case, the experiment ended and with it the last significant attempt to mine gold in the central Grampians. In hindsight, the Hall's Gap gold rush was modest. It did not spawn a bustling tent city or make many fortunes, but it is geologically notable. It proved that even in the heart of the Grampians, given the right conditions, a nearby intrusive and some faults, a bit of gold could accumulate. The story of Hall's Gap's gold ended as an alluvial footnote to the region's mining history. The creek and the forest have reclaimed most of these scars, leaving only the geological tale of what once lured miners to this unlikely spot. Beyond Mafeking and Hall's Gap, were there any other gold rushes entirely within the Grampians range? The historical record doesn't highlight any comparable notable rushes inside the present national park boundaries. Surrounding areas like Moyston to the east and Ararat/Stawell to the northeast had major gold discoveries, but those lie outside the Grampians proper and are in different geological units. Within the Grampians, what we see instead are minor occurrences and geological hints of gold rather than full-blown rushes. With this being said, when you drive through the Grampians, you find signs that gullies were worked that are far outside of the two known rushes. They were most likely worked in secret, so gold has most likely been found throughout all of the Grampians. But today, prospecting is illegal in the entire area. It's also noted that the largest gold nugget ever recorded from inside the Grampians National Park was only on the order of a few grams in weight, essentially a flake, underscoring how sparse coarse gold is within this terrain. This is entirely due to the geology of the region and a relationship between the gold and intrusive plutons. And thus, the gold rush episodes within the Grampians might be considered mere footnotes to Victoria's roaring gold era, but they offer a compelling narrative when viewed through the lens of geology. They illustrate how the same immense forces that shape mountains also hide and sometimes reveal mineral treasures. In the case of the Grampians, tectonic and orogenic forces gave the range its dramatic structure and, simultaneously, planted small seeds of gold within it. When the Mafeking rush of 1900 erupted, it was like a geological time capsule opening. The prospectors who panned those gullies were reaping gold that had been liberated by millions of rainy days and countless seasons of weathering, all stemming from a Devonian mountain building event. The fact that roughly 1 tonne of gold came out of Mafeking's gravels is geologically impressive for such a small area. It underscores how effective natural processes can be at gathering sparse particles into richer pay dirt. In conclusion, the gold rushes within the Grampians were geologically driven events. They were born from orogenic heat and pressure, sculpted by erosion, and discovered by human curiosity. While they lack the scale of Victoria's major rushes, they exemplify the nuanced and fascinating ways gold can occur, not always as headlining lodes in well-known districts, but sometimes as fine grains in an alpine creek or hidden in gravels of a sandstone range. The Grampians taught us that even a landscape of hard sandstone can, under the right circumstances, play host to a golden story, written by the hands of geology. I hope you found this as interesting as I did, and as always, thanks for watching. Before I end this video, I'd like to give a big shout out to my Patreon and YouTube members. Thank you so much to everyone that helps to support this channel.